Hello guys, welcome to another session. In this session, we are going to look into broadcasting concept within NumPy. So let's jump into the Jupyter notebook to understand this concept. So we are into the Jupyter notebook. Let's start our discussion. In our earlier session, we have discussed about arithmetic operations on array and where we have performed various operations like addition, subtraction, multiplication, division, as well as dot operation. And when we are performing these activities, or say these operations, we are making sure that the size of both the array should be similar. If you will not keep the size of both the array similar, then you will get the broadcasting error. So what does broadcasting means? So broadcasting is a technique which NumPy uses. Suppose if you are having a bigger array and a smaller array with a scalar value, then what NumPy do internally, it should replicate the scalar value into a smaller array and make the scalar value as the similar size like larger array and then perform the arithmetic operations. So let's understand with an example. Suppose that if you are having an array called A, I'm going to make it simple with a single dimensional array, and here if you are specifying range 5 and print that array, shift enter, and size we can also print size and shape as well, shift enter, then you will find that it has returned both. So let me print this as well, print, shift enter. Now suppose that if you are having another variable called b and which is a scalar value. Now as per definition, when we try to add the array a with this scalar value, it should fail, but you will find that this is not going to fail in case of NumPy. Why? Because NumPy takes care of broadcasting internally whenever such operations comes in place. So let's look into that. So let's try to do the addition of two different size of variables. One is an array, another one is the scalar value. So let's do it, and over here you will pass a comma b. A is an array, b is a scalar value. Shift enter, then you will find that it has added to each of the element this value 2. So what happens internally? So the thing what happened over here, internally NumPy created another array. For example, what it does, it has taken this value and internally it has converted it into something like this. It has repeated 2 comma 2 comma 2 or 2. So it has 5 elements, so it has also replicated the same value within the memory as a single dimensional array and make it of the similar size. And then afterward what it did, it has performed the addition operation over here. So what it does, it has, so let me control Z so that, and over here what it did, it has converted into something like a0 plus b0 comma a1 plus b1 comma a2 plus b2 and so forth. So this way it has done the addition and then it has returned the result, and this technique is called broadcasting. So NumPy automatically do the broadcasting, but there are certain limitations when using the broadcasting. It will not work with every cases. So there are certain rules which must be satisfied for broadcasting to be performed, and the rules are: broadcasting can only be performed when the shape of each dimension in the arrays are equal, or one has the dimension size of 1. So here one point to remember, whenever you do the broadcasting, so internally NumPy first matches the columns part and then check for the row part and then do the broadcasting. So what does it means? So let's look into an example over here. So this time we are going to use the two-dimensional array. So over here we need to specify a equal to np dot random dot randint, and over here I'm going to use 1 to 10, size equal to 2 comma 2, shift enter. Now another array a comma np dot random dot randint, and 11 to 10 20, make it 30, size equal to, this time I am going to keep it as 1 comma 3. Now let's try to add it. So we got error due to typo, shift enter. So now let's try to add it and let's look into the output, what output we are going to get. Shift enter, and the moment you will do that, you will get the broadcasting error. Why? Because the dimension is not same, and as per rule the last dimension should match. That means the column part must have to match, then only it will work. Now if we will change from 3 to 2, and when you try to run it, then you will find that it will run. Why is it so? Because this is the broadcasting rule which NumPy supports. The column part should match always, then only broadcasting will work, even though it is having one row and two columns. That is not similar to the size of the array A. So let's print it. Print a dot shape, shift enter, and also we will print the size, a dot size, and here you will find that we have different shapes, and for this also we have different shape. So let's take this and paste it over here, and this time we are going to use B over here. B, shift enter, then you will find that we have different shapes for both the arrays, but this time it worked. Why? Because this is the rule where size of the column vector should match, and this time it is matching it. This one is also 2 and this one is also 2, so it is satisfying the broadcasting rule which NumPy performs while executing the broadcasting. And this is what I wanted to demonstrate you in this session. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care.